Hey, thanks for clicking on my video. If this video helps you, please consider liking this video and subscribing to my channel. It is greatly appreciated and it really helps. Let's get to the video. Let's talk about the unit circle. So first of all, what is the unit circle? It's just a circle that satisfies the equation x squared plus y squared equals 1, which means our center of our circle is going to be at 0, 0, and it's going to have a radius of 1. So now we can identify the value of sine of theta and cosine of theta. So for sine of theta, it's just simply going to be the y-coordinate of the point where the terminal side of theta intersects our unit circle. So we know that from a previous video when we talked about evaluating trigonometric functions given a point, that we came up with certain ratios for our 6 functions, where sine of theta was y over r, cosine of theta was x over r, tangent of theta was y over x, and then we could find the inverse of those for cosecant, secant, and cotangent. So here we know that sine of theta should be y over r, and since it's our unit circle, r, or our radius, is 1, so it becomes y over 1, which simplifies to y. So the sine of theta is just simply going to be the y-coordinate of our point where the terminal side intersects the unit circle. Likewise, for cosine of theta, it should be the x-coordinate of our point where our terminal side intersects the circle, because our ratio for cosine would be x over r, and once again the unit circle radius is 1, so x divided by 1 would be x. So if we take a look at our diagram here, we see that represented. So we have in white our circle, in green is representing our angle of theta. It's telling us that the radius is equal to 1, so we know it's our unit circle centered at the origin, and we have our point x comma y that's on our terminal side of theta that intersects our circle. So over here in black and with our star next to it, it says it's convenient to use the unit circle to find trig functions for quadrantal angles. So these angles we're talking about would be angles that lie on an axis. So that's going to be like 90, 180, 270, 360, because the measure of those is a multiple of 90 degrees or pi over 2 radians, and we saw that in a previous video that we did about special angles in radian and degree measure. So let's use this convenience of the unit circle to do an example where we evaluate the 6 trig functions of when theta is equal to 90 degrees. So in our diagram here, we see that theta has been opened up 90 degrees. So we would have the point 0, 1, because our radius is 1, and so we're taking that terminal side and we are rotating it up 90 degrees counterclockwise. So in standard position, we would have the point on our terminal side intersecting our circle at 0, 1. So now we see that our x-coordinate is 0 and our y-coordinate is 1. So if we think about those ratios that we talked about, where sine is y divided by r, cosine is x divided by r, tangent is y divided by x, cosecant would be r over y, secant would be r over x, and cotangent would be x over y. And so now we can use the point that we have, the fact that the radius is 1, and we can evaluate these 6 trig functions where theta would be 90 degrees. So if y is 1 and r is 1, then the sine of theta would just be 1. If x is 0 and radius is 1, then the cosine of theta would be 0. Y is 1 and x is 0. So we can't divide by 0 here, so we're going to have to cross that off and say that the tangent of theta in this case would be undefined. All right, now for cosecant, we know that we could just take the reciprocal, or we can continue to evaluate when whatever y is, whatever x is, and whatever r is. So once again, we know that r is 1 and y is 1, so cosecant of theta for 90 degrees would still be 1. In this case, secant, we would have 1 as our radius, x is equal to 0, so once again, we're going to have to say undefined for secant, because we can't divide by 0. And then for cotangent, we would have x over y. And so x in this case is 0, y is 1, and that's going to equal 0. Okay, so that's how you can use the unit circle to help you find the 6 trig values for some different angles.